Okay, hello, my little cubs. Linear regression on the calculator. So we are talking STAT-7 today. So today is going to be a heavy calculator day. And we're going to start with this warm-up. So this is going to be your responsibility, but I'll talk you through it really quick. So for 10 days, Romero, kept a record of the music of hours he spent listening to music. Wow, I can't even read. This is the information below, okay? So here are the days, here are the hours. Which scatter plot shows his data graphically? So all you're going to do is see the points plotted. So this is an X for days, Y for hours. So 1,9 should be a point on the graph. It is not on this one, so it can't be this one. 1,9, that works. 1,9, that works. 1,9, that works. Okay, and you are going to get the correct answer. I think this should be part of your homework. Excellent. So the line of best fit has been drawn on the scatter plot below. The relationship between these variables can be described as having negative correlation, no correlation, positive correlation, zero correlation. We already talked about correlation. If you have a positive slope, you have positive correlation. That is a hint for you. So what we're going to be talking about today is making little plots, scatter plots, on your graphing calculator, okay? And then we're going to be talking about creating an equation for the line of best fit. So today is a calculator heavy day, okay? And if you have a calculator from the school, that's fine. You're going to follow the same buttons that I do, alrighty? So exercise 1 says a survey was taken of 10 low and high temperatures in Fahrenheit in the month of April to try to establish a relationship between a day's low temperature and a day's high temperature, okay? So here's my low temperature X and my high temperature Y. The first thing I want to do is create a scatter plot in my calculator, okay? And how do I do that? Okay, so in your calculator, here you go. I want to create a scatter plot. And the first thing I'm going to do is I'm going to hit the blue button. So I'm going to hit second, and then I'm going to hit Y equals, okay? So above, I hit the blue button because in blue it says stat plot. So I hit second, Y equals for stat plot, okay? I want to turn, I hit enter, okay? So I'm talking about this one right here. I'm going to have the first one highlighted. I'm going to hit enter. Right now, you see how the black is hovering over off? I want to turn that on. So I want to be blinking over on, and I want to hit enter, okay? And down here are the different types of graphs that you have. So there's your box and whisker also. There's the step function, bar chart. I want the first one where if you're looking at this thing, okay, it's all these little dots all scattered all over the place. So I want to make sure that that is highlighted and it's black. L1 and L2 you want to keep, so that's where I'm going to put the list of my data, and the rest you want to keep, okay? So now what I want to do is, now that I have my stat plot all set up, I actually want to go into the stat function. So I'm going to hit stat, and I want to just put in these lists, okay? So enter, because I want to get to my list. So again, to get to the list, you're going to hit stat, enter to edit. If you have information in here, the easiest way to clear it is you arrow up, you put L1 or whatever that top little column is, you hit clear, and you hit down. So it clears the whole thing right away, okay? So now what I'm going to do is put the low temperature in L1, okay? This is going to be L1. And this one's going to be L2. So I'm going to have two lists here. So I'm going to have 26, enter, 28, 30, 32, 34, 35, 37, 38, 41, 45. Okay, and then I'm going to arrow over to get to the second list, and I'm going to put this list of numbers. So 49, enter, 50, enter, 57, enter, 54, 60, 58, 64, 66, 63, 72. Okay, so I have my data here, all right? So I have my stat plot on, and I have my data. The next thing you're going to do to get the graph is you're going to hit zoom, okay? right here, that zoom number, and then you're going to hit number 9. So you see number 9, it says zoom stat. That means you want to zoom on the statistic function, okay? So here is the scatter plot, and that's what I'm going to just do a little draft of, okay? So here is X, here is Y, and I'm just, nothing specific, I'm just going to make it kind of look like this. Okay, so that's about what the scatter plot looks like, something very similar. This was basically just an idea to get you to know how to plot the scatter plot. Okay, now what I want to talk about is use your calculator to find the equation for the line of best fit. Okay, well, remember the line of best fit. The line of best fit is basically that line that's going to split your data like right in half. Something like this. I don't know, my pen's dying, so that's not working out very well. But something like that where you're going to try your best to get the same amount of dots on top of the line as the same as the, like below the line. The equation for the line of best fit also comes from your calculator. We are still in statistics. So I'm going to hit stat, okay? I don't need to edit because I have those lists in here. So what I'm going to do is go over to calc. It's asking, so far we've been in one var stats because it's talking, we've been looking at mean, median, and mode and that kind of stuff, quartiles. We're not looking at those anymore. We're looking at lines of best fit, okay? We're looking at linear regression, okay? So we're going to be looking at number 4. So I'm going to arrow down to number 4. You will never be at number 8. So number 8 says A plus BX. That's not what we work with. We work with MX plus B or AX plus B. So this is the one I want to highlight, number 4. And I'm going to hit enter. And I'm just going to hit enter all the way through here because my X list was L1. My Y list was L2. I'm good to go. Okay. So here it is. I want you to write this information down. So I have the equation y equals ax plus b, and I'm going to talk about the a, and I'm going to talk about the b, okay? They come right from this equation. So I get 1.162612036 and 19.07362356. Okay, that's too much to put in the equation. Let's see how they want us to round. The slope of the line to the nearest hundredth, okay? So mx plus b, this is your slope. So I get y equals to the nearest hundredth, 10th, hundredth. The 2 is going to tell me what to do to the 6, and it's going to stay. And then this is your y-intercept. And the y-intercept to the nearest integer, aka the nearest whole number, which is just plus 19. So this is your equation for the line of best fit from the calculator. Okay, part C says, explain what the y-intercept of this model represents in terms of the low and high temperatures that are modeled in this problem. Okay, well, a y-intercept, okay, the y-intercept happens when I no longer have an x value or when x is 0. Okay, so when x equals 0, that's when I cross my y-axis. And if I'm talking in terms of the context of this problem, when x is 0, what is actually 0? The low temperature, okay? So when the low temperature is 0, okay, so that's what we'll say. Okay, and if, well, let's pretend, so this would be 0. So if the low temperature is 0, it means that y is going to be 19, and y is the high temperature. So when the low temp is 0 degrees Fahrenheit, the high temp is predicted to be 19 degrees Fahrenheit. Okay, so basically your y-intercept is just what's happening. It's your y value when x is 0. X in our case is low temperature. That means that y is my high temperature for that corresponding 0. Okay. D says, how would you interpret the slope of this model in terms of how the low and high temperatures change with respect to each other? Okay. What does slope represent? Okay. Slope. Up some, over some, up some, over some. The first thing I want to point out to you is that the slope is a rate. Okay. It's a rate of change. Let's say that more specifically. Slope is a rate of change. Okay. When we say find the slope of an equation, we say slope is change in y over change in x. Okay, remember this? So this is a rate of change with how y changes, which is my high temperature, okay, to how the x changes. This is my low temperature. Okay, we're just being specific on what this is. So what does that mean in relation to my equation? Okay, so if this is my equation, remember? So if I have a slope here, this number is always over 1. So my change in y is my change in my top number over my change in my bottom number. So y is positive. That means it's increasing. And it's increasing 1.16 degrees for every 1 degree the lower one is changing. Okay, so for every 1 degree, your low temperature is changing. The high temp raises 1.16 degrees Fahrenheit. Okay, because that's what a slope is. It's a rate of change. Okay, x on the bottom, y on the top. Okay. All right, so this last example, we only have 2 today, is generally the fuel efficiency of a car changes with the weight of the car. A survey of some cars with their weights and gas mileage is shown. So basically what's happening here is I have weight of a car, and this is thousands of pounds. So this is 3,700, 4,500, 3,200, so on and so forth. This is your mileage. So for this 3,700 pound vehicle, they get 38 miles per gallon. That's nice. For this 4,500 pound vehicle, they get 26 miles per gallon, so on and so forth. Okay. First thing I want to do here is find the equation for the line of best fit using the calculator. Okay. So the first thing I have to do is if I want to find the line of best fit, I have to enter my data in my lists. So I have to change my list. I'm going to go to Stat, hit Enter. I'm going to clear out both of these. So highlight SL2, clear, arrow down, clear, arrow down. I'm going to put this one in L1, and I'm going to put this one in L2. And I'm going to use the numbers I see. So 3.7, 4.5, 3.2, 5.1, 6.8, 4.9, 4.8, 5.5. Now my second list, I'm just going to put in these: 38, 26, 48, 24, 18, 30, 28, 21. They're even. Everything looks good. So the equation for the line of best fit, I'm going to go to Stat, over to Calc, down to 4, so linear regression, AX plus B, and I'm just going to hit Enter through to calculate. Okay, So now I'm going to put this information into an equation. So I'm going to get y equals ax plus b, where a is equal to negative 8.0973. I'm going to keep it there. B is 68.0935. And it says round both the coefficients to the nearest tenth. Okay, so now I'm going to put my equation together. So y equals a is negative 8 to the nearest tenth. So tenth is the first decimal. This 9 is going to tell me what to do to the 10. 9 will push that up to a 1. X is part of the equation. And nearest tenth for this one is 68. First one, 9 will tell me what to do. 0.1. Okay, and then it says list what variables x and y represent in this problem. Okay, so we're going to talk about weight and mileage. Okay, so what happens here is your y depends on your x. Okay, so that means that x is your y is your dependent variable and x is your independent variable. Because what happens here is that your mileage or your output, how far you can go, is going to change and depending on how heavy your car is. So if 3.7 gets 38 miles a gallon, if I get a heavier car like 4.5 thousands, I get 26 gallons. So you see how this is a little bit of a different number because the heavier the car, the less mileage you get. So we're going to say X is weight and y is mileage. Okay, and we'll say output depends on weight, which it does. Okay, so next what we're going to do is create a graph of the scatter plot for this data. And would you consider the correlation between weight and mileage to be positive or negative? Okay, so I want to create a scatter plot. Okay, so I'm going to go to second stat plot. Just make sure I'm turned on. I'm on a scatter plot. Perfect. I'm good to where I need to be. I already set it up. So now all I'm going to do is hit zoom 9. Okay, and I'm going to draft this little scatter plot here. This is X. This is Y. I have one here, I have like 3 here, here, and here. Okay, that's good enough draft for me. So now it says, would you consider the correlation between weight and mileage to be positive or negative? So your correlation basically is determined by your slope, right? So your slope here is going down. So that means that you're going to have a negative correlation. But why is it a negative correlation? Okay. The reason it's a negative correlation is because your data is moving in opposite directions. So what's happening here is as the weight of the car increase, this goes down. The mileage goes down. So as something is getting bigger, the other one is getting smaller. Okay, so this is negative because as weight of car increases, mileage decreases. Okay, this is AKA data moves in opposite direction. So one goes up, one goes down. Okay, so that's a negative correlation. It says which parameter of the linear model predicts whether the correlation is positive or negative. Okay, well, I had a positive slope here and a positive slope here and a positive correlation. I have a negative slope here, a negative slope here. That means I have a negative correlation. So the slope predicts the correlation. We will say positive slope, positive correlation. Okay, negative slope, negative correlation. That's the big idea. Okay. You will definitely be asked about some kind of correlations. Okay, and then for D, it says if a car had weight of 4,300 pounds, what would this model predict as its fuel efficiency? Round to the nearest integer. Okay, so fuel efficiency, aka mileage, and this is a weight of 4,300 pounds. Okay, so this right here, 4,300 pounds, the weight is my X. Okay, the mileage is my Y. So it says, what would this model predict as mileage? So I'm trying to solve for Y when X is this. So negative 8.1. Now, here's what you have to be careful about. This is 4,300 pounds. My equation is in thousands of pounds. Notice how all of these are decimals. This one also has to be a decimal if I'm plugging it in. Okay, and I'm just going to plug this little guy in here. So I get negative 8.1 times 4.3 plus 68.1. I get 33.27, okay, to the nearest integer, which is the nearest whole number, so 33 miles per gallon. Okay, that is your answer. Does that make sense? So 4.3 lives between these two right here. And 33 miles to the gallon also lives between these two numbers right here. So yes, it does make sense. Okay, have a wonderful, fantastic day. Bye-bye.